Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about mean value of a random variable with binomial distribution. In my previous videos, we have already discussed about concept of binomial distribution. And the expression of the binomial distribution. And what is that expression of the binomial distribution? Capital X is the random variable. The binomial distribution is given by probability of x is equal to m or probability of m is equal NCM into p power m into q power n minus m for m is equal to 0, 1, 2, 3 and so on n, or p of m is also written as in terms of another expression in terms of the value of the x. So probability of x is equal to m or probability of x is equal ncx into p power x q power n minus x for x is equal to 0, 1, 2, 3 and so on small n. So now here small x is the value taken by the random variable capital X, and p is the probability of the success and q is the probability of the failure. Since the probability of the success plus probability of the failure, summation of the probability of success and probability of the failure is always equal to 1. So this concept already discussed in my previous videos. So now here in this video I am going to discuss about mean value of a random variable with binomial distribution, and this equation is the binomial distribution expression. Now calculate the mean value of the random variable with binomial distribution. So but we know that the mean value of the random variable is given by expectation of x or m. This expectation of x is also denoted as m or mu or x bar, which is equal to sigma I is equal to 1 to n xi into p of xi. So this is the expression of mean value of the random variable for discrete case. So now here expectation of x is equal, the range of the m or range of the x is 0 to n. So the expression is here sigma m is equal to 0 to n m into p of m, or sigma x is equal to 0 to n x into p of x, where x is the value taken by the random variable x. So expectation of x is equal, so what is the expression of the binomial distribution? Probability of x is equal to x, or probability of x is ncx into p power x into q power n minus x for x is equal to 0 to n, and substitute p of x into this equation, we get expectation of x is equal sigma x is equal to 0 to n x into ncx p power x into q power n minus x. So now here on RHS side, first substitute x is equal to 0. Substitute x is equal to 0. The first term in the summation is 0. And what is x first term? Substitute x is equal to 0. 0 into something. 0 into something 0. So the first term in the summation is 0. That is if x is equal to 0. And the remaining values of x. So what are the remaining values of the x? X is equal to 1 to n. So therefore, and after substituting x is equal to 0 and the remaining values of x, the expectation of x is sigma x is equal to 1 to n x into ncx p power x q power n minus x. We know that the expansion of ncx is n factorial by x factorial into n minus x factorial. Applying this expansion here, we get expectation of x is equal sigma x is equal to 1 to n x into expansion of ncx is n factorial by x factorial into n minus x factorial into p power x q power n minus x. N factorial is written as n into n minus 1 factorial. X factorial is written as x into x minus 1 factorial. Now here in this term, n minus x factorial term, by adding and subtracting by 1, we have n minus x minus 1 plus 1. So now where the minus 1 plus 1 is cancelled, we get this term. So now here adding and subtracting by 1. And p power x, this p power x is written as p into p power x into p power minus 1. So p into p power minus 1 is p power 0. So p power 0 is written as p power 0 is 1. So this p power x is written as p into p power x minus 1. And in this term, power of the cube by adding and subtracting by 1, we have q power n minus x minus 1 plus 1. So now here numerator and denominator x is the cancel. The remaining RHS term is sigma x is equal to 0 to n np into n minus factorial by x minus 1 factorial into. So this n minus x minus 1 plus 1 is written as minus 1 minus of x minus 1. N minus 1 minus of x minus 1 factorial into p power x minus 1 and q power, that q power term is written as q power n minus 1 minus of x minus 1. So using this expansion, this is the expansion of the NCX. Using this expansion, this term n minus 1 factorial by x minus 1 factorial into n minus 1 x minus 1 factorial is written as n minus 1 c x minus 1. Therefore, expectation of x is equal to np into sigma x is equal to 1 to n. So this term is written as, using this expansion, this standard expression, n minus 1 c x minus 1 into p power x minus 1 into q power n minus 1 of x minus 1. So we know that using binomial expansion of p plus q whole to the power of n is sigma x is equal to 0 to n ncx into p power x q power n minus x. And this is the binomial expansion. So using this standard expression, the RHS term of this equation. So the RHS term of this equation is written as p plus q whole to the power of n minus 1. So therefore, using p plus q whole to the power of n minus 1 is sigma x is equal to 0 to n minus 1 c x minus 1 p power x minus 1 q power n minus 1 minus of x minus 1. So therefore, from this equation, mean value of the binomial random variable, expectation of x is equal np into, so using binomial expansion, this term is p plus q whole to the power of n minus 1. So that is np into p plus q whole to the power of n minus 1. But we know that the summation of probability of the success and the probability of the failure is always equal to 1. That is p plus q is equal to 1. Applying this condition here, 1 power n minus 1 is 1. So therefore, expectation of x is equal to np. So this is the mean value of a binomial random variable.